So just a moment. Yeah. For the last couple of days, we have been practicing questions from functions. And I hope everybody got it and understood them very, very keenly. Yes or no? Yes or no? So today we will start with a topic which is in JEE syllabus, that is periodic function. So periodic functions. Now, do you realize few functions are there which are repeating their behavior again and again? Like just a simple example, if I tell you, say there is a function whose graph is something like this. Something like this. Like here it is going, then this, and so on. Now, do you realize if it is 0, it is 1, it is 2, 3, 4, -1, -2. Do you realize there's a certain behavior this function is showing, which is repeating again and again? Yes or no? If I plan to make a stamp, if I plan to make a stamp of this length, if I plan to make a stamp of this length, and then I start copying it. So are you going to get the entire graph? Yes. So these functions are what we call periodic functions. This is their like graphical definition. And the length of this frame, say this length is t. Length of this frame, it is called period of the function. This length is called the period of the function. Am I correct? Now, this is the graphical thing that we should understand. Now, what is the mathematical approach? Like if f of x plus t is equals to fx. F of x plus t is equals to fx for all values of x. For all values of x in the domain. Then we call such functions periodic. And t is called the period of this function. Then we call such functions periodic, and t is called the period of the function. Generally, this t being the smallest possible value. Like, why do I call it smallest possible value? See, sine of x plus 2 pi is sine x. Similarly, sine of x plus 4 pi is also sine x. Sine of x plus 6 pi is also sine x. But we cannot call every 2 pi, 4 pi, 6 pi as period. So out of these, the smallest value that we are having, smallest positive value, t is the smallest, I should say, positive possible value, then we call it period or fundamental period. Fundamental period. Am I clear? T is the period or fundamental period. Is it okay, everyone? Period or fundamental period. Now, first of all, we have to understand and remember the period of few well-known functions. Period of well-known functions. Period of well-known functions like fx equals to sin x. Can somebody tell me the period of this function? Anyone? Tell me the period of this function. 2 pi. Then there comes fx equals to cos x. Also periodic with period 2 pi. Fx equals to sec x. Also periodic with period 2 pi. Fx equals to cosec x. Periodic with period 2 pi. Then there comes fx equals to tan x. Tan x. Periodic with period pi. Fx equals to cot x. Periodic with period pi. So tan x and cot x, they are periodic with period pi. Then more functions that you are aware is fractional part of x. Do you remember this function? Periodic with period 1. Then there comes fx equals to say some constant 3, something like this. Then or I should directly write fx equals to a. So this is a constant function. Constant function. In these kind of function, we say periodic functions, periodic function, but no fundamental period defined. 2 pi, if you see this now, sine of x plus 2 pi is sine x, Dhanush.
Yes, sir.
Even if you see the graph of sine x, this is the wave that you are initially getting. And then this wave is again and again repeating. So 0, pi, 2 pi. In the graph of sine x, this is the frame that is repeating again and again. Yes or no? And the length of this frame goes 2 pi. Is this okay?
Sir, for
Sorry?
tan cot.
10, because I know 10 pi plus x equals to 10x. 10 repeats its position after every pi. If you remember the graph of 10x, it is like this. Like this. Remember this thing? 0, pi, 2 pi, and so on. So this much is the frame length. This much is the frame length, if you realize, that is repeating again and again. And the length of this frame is going to be pi. Yes or no?
Yes, sir.
So that is why tan x is periodic with period pi. Understood?
Yes, sir.
Now, let us see some properties. Okay, tell me one thing. Fx equals to greatest integer x. Is it going to be periodic? Fx equals to greatest integer x. Is it periodic or not?
Yes, sir. Yes, sir. Sir, your mic is off.
If you make a frame of this length, you have to shift that frame in the direction of y-axis also. So that is not periodic. If you say period is 1, tell me, is greatest integer of x plus 1 is greatest integer x? No. Got my point?
Yes.
So this is a common question. Generally, students misunderstood it. Greatest integer x was not periodic. Now, properties of periodic function. Properties of periodic function. Unknown. Shall we start? Number 1. Inverse of a periodic function does not exist. Can somebody explain me why? Inverse of a periodic function does not exist. Why? Tell me. Inverse of a periodic function does not exist because in periodic function will always be on to many one function. Because in case of a periodic function, any line parallel to x-axis will be intersecting the graph definitely at multiple points. Yes or no? So these functions are always many one functions. So they are not invertible. Got it? Second property. Every constant function is always periodic, but no fundamental period defined. Correct? Now, if period of fx is p, then 1 by fx, kfx like 2fx or 3fx, and under root of fx will also be having period as p. Am I correct? Now, if period of fx is t, then that of fx ax plus b is t by mod a. If period of fx is t, then that of fx is t by mod a. Am I clear? Like, for example, here we can do so many examples. Sine 2x. If I ask you about sine 2x, what is the period? 2 pi upon 2. That is pi. But if I ask you sine x by 3, then period will be all what? 2 pi upon 1 by 3. That is 6 pi. Am I clear? Cos pi x. Tell me what will the period? Cos pi x period is
1.
yes, tell me.
1.
No, what is the period of cos x? 2 pi. Then you divide it by pi. So period will be what? 2. Understood?
Yes, sir.
Tan 3x. Quickly tell me the period. Tan 3x.
Pi by 3.
Pi by 3. Fractional part of 5x. What will be the period? What is the period of fractional part of x? 1. So fractional part of 5x period will be 1 by 5. Am I correct?
Yes.
Now, property number 5. If period of fx is t, if period of fx is t, then period of mod fx do not have any generalized form, so it can be anything. Like if I ask you what the period of mod sin x, if you realize this is the graph of mod sin x. So say it is 0, pi, 2 pi, minus pi, minus 2 pi. So mod sin x period is what? Pi. But if I talk about mod 10x, its period is also pi. Because what is happening in 10x? In between minus pi by 2 to pi by 2, this is the graph. And when you take mod of this denominator portion will come upside. So the graph of mod 10x will be like this. So that is why its period does not change. Period here is also pi. So this mod of Tanush graphs, I have also told you, you have to remember these graphs. At least you should know. See, the list of graphs that you should necessarily know. All 6 trigonometric functions. These graph you must know. Modulus function, greatest integer function, fractional part function, then modulus function, greatest integer function, fractional part function, log functions, and exponential functions. These graphs you must know. Got it? Now, if I ask you about the mod cos x, again, period will be pi. Mod cot x, period will be pi. Mod secant x, period will be pi. Mod cosec x, period is also going to be pi. Yes or no?
Yes.
Now, another rule. If two functions are added, like fx plus minus gx, if two functions are added or subtracted, then are added or subtracted where their periods are T1 and T2. Where their periods are T1 and T2. Then it is not necessary that fx plus minus gx will be periodic. But if it is periodic, then period may be LCM of T1 and T2. Then period may be LCM of T1 and T2. Like there is an example, say fx equals to cos 2x upon 3 minus sine 4x upon 5. Fx equals to cos 2x upon 3 minus sine 4x upon 5. Tell me one thing. What is the period of this function? 2 pi divided by 2 by 3. Yes or no? T upon mod A I told you. So this will be 3 pi What is the period of this function? 2 pi upon 4 by 5. That is 5 pi by 2. Correct?
Pi by
Now, period will be what?
pi by 2, sir.
5 pi. Period will be LCM of LCM of 3 pi, comma 5 pi by 2. Now, what is
Pi by 2, I
LCM?
think.
LCM of A by B and C by D. That is LCM of numerator upon HCF of denominator. Now, what is LCM of 3 pi and 5 pi? 15 pi. And what is SCF of 0? Oh, sorry, 1 and 2? It will be 1. So your answer will be 15 pi. Nahi, Dhanush, not pi by 2, not in any case. Have a look. Understood? LCM of fractions क्या है? LCM of numerator upon HCF of denominator. Got it?
Yes, sir.
Next example. What is period of fx equals to mod sin x plus mod cos x? Okay, what is the period of mod sin x? Tell me. Pi. What is the period of mod cos x? Is pi. Now, that is pi. But sometimes what happens? Functions are interconvertible. Like if I check for f of x plus pi by 2, what do you get? Mod of sine x plus pi by 2. Mod of cos x plus pi by 2. Now, sine x plus pi by 2 is minus cos x, which is mod is cos x. And cos x plus pi by 2 is minus sine x. Sorry, pi by 2 plus x is minus sine x. Mod absorb the minus, so it is this. So f of x plus pi by 2 is equals to fx. That means this function is periodic with period pi by 2. In this kind of question, sometimes we have to think out of the box and we'll look for the period. Now, another example I give you, for example, fx equals to sine square x plus cos square x. Tell me what is the answer. Just quickly. Just quickly. See, individually, if I see its period is pi, if I see its period is pi, but here if you see this fx is 1, yes or no? For every x which belongs to number line, sine square plus cos square is 1, yes or no?
Yes, sir.
And if it is 1, If it is 1, in that case, what do we say? Periodic function, but no fundamental period defined. Periodic function, but no fundamental period defined. Got it? Now, but if I also see an example, fx equals to sec square x minus 10 square x. Now, can you tell me the period? Value of this is also 1. But if I see its domain, it is r minus 2n plus 1 pi by 2. Matlab for every r which is not equal to odd multiple of pi by 2, this value is 1. Otherwise, this function is not defined. So if I see its graph, it is going to be like this: 0, pi by 2, 3 pi by 2, 5 pi by 2, minus pi by 2, minus 3 pi by 2, minus 5 pi by 2. So graph is going to be like this. Like this. Now here if you realize, we are getting a frame. This is the frame. If I take a stamp, it is repeating again and again. Yes or no? So that is why this function is periodic with period pi. Periodic with period pi. Have a look. See the difference in both the questions. They both are constant functions, but still one is periodic with period pi. Other is periodic, but fundamental period is not defined in spite of being both as constant functions. Done? Now, write down the question. Given fx equals to a plus 3 into x plus 5a for every x belongs to R. If it is periodic, find the value of a. Tell me, if this function is periodic, find the value of a. Just quickly. Okay, tell me one thing. Lakshmi,
Yes, sir.
tell me one thing. Can a linear function be periodic? Like this is the graph of a line. Like there is a line like this. Can it be periodic ever?
No, sir.
No, sir.
No. So if I want to make it periodic, it should not be linear. It has to be constant function, only then I can make it periodic. Yes or no?
Yes, sir.
Now, how to eliminate x from this function? If I take a as -3, your fx function will become -50, which is periodic. Period is not defined, that is okay, but it came periodic, yes or no? So that means your a is what? -3. This is your answer. Am I correct? Am I correct?
Yes, sir.
See another question. Let a function satisfies let a function satisfies f of x plus 4 plus f of x minus 4 is equals to fx. For all real x, for every real x, then is this function periodic? Is this function periodic? If yes, find period. Give it a try quickly. Got it? Any idea? Now see, how do we approach these kind of questions? The given functional equation is f of x plus 4 plus f of x minus 4 is equals to fx. Do one thing, replace x by x plus 4. So it becomes f of x plus 8 plus fx is equals to f of x plus 4. See this? Now let us add both of them. So f of x plus 4 plus f of x minus 4 plus f of x plus 8 plus fx is equals to fx plus f of x plus 4. Now if you realize, this fx is cancelled with this fx of x plus 4 cancelled with this. So what are you left with? F of x minus 4 plus f of x plus 8 equals to 0. Yes or no? Now again, replace x by x plus say 12. So if you do it, you get f of x plus 8 here because x plus 12 minus 4 plus f of x plus 20 equal to 0. Now if I subtract both of them, then they are cancelled. So what are you left with? F of x minus 4 minus f of x plus 20 equals to 0. That means f of x minus 4 is equals to f of x plus 20. Now replace x by x plus 4. So you get fx is f of x plus 24. This is your final equation. This equation came in the form of f of x plus t equals to fx. Yes or no? Comparison period. What is your t? 24. This is the period. So yes, it is periodic with period 24. Have a look. Am I clear? See this. It is a bit of tough call, but it is an important question. Once again, I tell you, this is the given problem to me. F of x plus 4 plus f of minus x minus 4 is equals to fx. Got it? Now I replaced x by x plus 4. So here I got x plus 8. Here I got fx. Here I got f of x plus 4. Yes. Now if you add all the two equations, this plus this is equal to this plus this. You realize fx cancelled, f of x plus 4 cancelled. So you got this equation. Now I want it in the form like fx equals to f of x plus t. So I do it again. Now I replaced x by x plus 12. Why did I do it? So that I can get these two things in and I can cancel them. Got it? So I replaced x by x plus 12. What do you get? F of x plus 8 plus f of x plus 20 equal to 0. Again, subtract them. So what do you get? F of x plus 4 minus f of x plus 20 equals to 0. So you got f of x minus 4 equals to f of x plus 20. Just a moment. Got it? Now I replace x by x plus 4. So I got fx is equal to f of x plus 24. So that means it is periodic with period 24. Am I clear? Is it okay? All right. That would
Yes,
be
sir.
all. Just let me recall for a moment. So today we have done periodic functions. Yes. So functions which satisfy this kind of criteria for their entire domain are called periodic functions. Here t is called the fundamental period and this should be the smallest value. Period should be the smallest value. Am I clear? Now period of a function, जो known function है, that is 2 pi, sec x 2 pi, this is 2 pi. Got it? Tan x pi, cot x pi, fraction part of x1. You have to remember these basic periods. Then I told you at least graphs of all the basic functions you must know. All 6 trigonometric functions, modulus, greatest integer, fraction part, log, exponential. All these graphs you must be aware of. Got it? Then we have done some properties of periodic functions. And that's few questions we have done. Anything anybody would like to ask? Quickly tell me. Any doubt? Yes, please. Is everything fine?
Yes, sir.
All right, guys, then. See you tomorrow. Tomorrow we'll practice more questions over the chapter and we'll wind it up. All right. Thank you so much.